In this video, we're going to have a look at multiplying complex numbers. So in this example, you're asked to find 3i times 4 minus 2i minus 6 plus I times 3 minus I. Go ahead and try this example on your own first before we take it up together. The key things to remember here is that when you're expanding and working with complex numbers, you're just doing the same steps you would do if you were expanding regular expressions. So you still make sure that each term in the first expression multiplies each term in the second expression. So for instance, if you had x plus 3 times x plus 2 when you were dealing with expressions, you would have done FOIL, so first, outer, inner, last, to make sure you multiplied all the terms. It's no different from complex numbers. You in fact follow the exact same procedure, so go ahead and do that. Just keep in mind that at the end you're going to have to collect like terms, so in other words you're going to have to collect all the real numbers together and all the imaginary numbers together to get your final answer. Another key thing to keep in mind is that when you multiply an I by another I, because I is the square root of -1, multiplying it by itself, giving you I squared, is just equal to -1. So it's in fact a real number. So go ahead, try this out, and we'll take it up once you're done. Okay, so let's go ahead and take this up. So first of all, let's write out the expression that we're trying to expand. What we're going to be doing, remember, is in the first term, we're going to multiply the 3i times the 4 and the 3i times the -2i. In the second set of terms, we have to do FOIL, so first, outer, inner, last. So we're going to multiply the first terms together, the outer terms together, the inner terms together, and the last terms together. So let's go ahead, try this out, and see what we get. From 3i times 4 minus 2i, the 3i times the 4, let's write that out, and then we have, let me just write it as addition, you could write it as subtraction, but what we've got is 3i times -2i, and again you could write it as subtracting 2i times 3i. For the next set of terms, let me write the negative out front and then do FOIL. So multiplying the first terms, we've got the 6 times the 3, the outer terms gives us the 6 times the -I, the inner terms gives us I times 3, and the last terms gives us I times -I. So now let's simplify as much as we can. 3i times 4 is 12i. 3i times -2i gives us -6i squared, minus, let's still leave the brackets here and just simplify as much as we can within them. 6 times 3 is 18, 6 times -I is -6i, 3 times I is plus 3i, and I times -I is -I squared. So moving on to our next step, we get 12i minus 6i squared. Remember, I squared is -1. Then we have negative, and let's simplify the things in the brackets first. So we have 18, we have the -6i plus 3i, which are like terms, so we end up with -3i overall, and we have -I squared, and again, I squared is -1. Be careful of all the different negative signs. We've got minus I squared, so it's -1. Again, just to emphasize, what we've done is we've replaced the I squared with -1. And we've done that in 2 locations in this expression. So now let's continue simplifying as much as we can. We've got 12i minus 6 times -1 is plus 6. And then we can expand the negative sign in through all the terms in the expression on the right here. So what we end up with is minus 18 minus -3i is positive 3i, and minus times minus -1. So this is a bit tricky. We've got 3 negative signs overall, so it's going to make a negative sign. So we have -1 overall. Finally, we want to combine the real terms together and the imaginary terms together. The real terms are the 6, the -18, and the -1, whereas the imaginary terms are the 12i and the 3i. So overall, what we have combining the real terms, so 6 minus 18 minus 1, the ones that are underlined in red, so 6 minus 18 minus 1 is going to give us -13 as the real component of our complex number. And for the imaginary component, we're looking at the terms underlined in blue, So the imaginary terms that have the I in them, we've got 12i plus 3i. Altogether, that's 15i, so that's the imaginary component of our complex number. Overall, then, our final answer is the complex number negative 13 plus 15i. Again, notice that all we did to complete this example is we used the same rules for expanding that we normally would, but we were just very careful to remember that I squared is equal to negative 1, and at the end, for combining terms, we combined real terms separately and imaginary terms separately to make up the two parts of our complex number.